Alrighty, and we are recording too. Okay, so the first part that we're going to be doing, let me show on my end over here. Let me just paste it over here and we should be good. Actually, sorry. Okay. So we're just going to do a really quick warm up here. So just after putting your name on the first slide, the second slide, we're just going to quickly warm up, just go over Excel formulas. Suppose that the cell A2 contains the number 2, cell A3 contains the number 3, and cell A4 contains the number 4. If you type the following formula into Excel, what results will it display? So we're just going to do a little review, go over it. Don't forget about PEMDAS here. And after that, we'll be good to get it started.
Hey, good question. We're doing the amplify thing right now.
Yeah.
Where should I get it from? Because the every time I open it, it takes me back to lesson one, the one from yesterday.
Oh, let me make sure it's the right one posted then. It should go to lesson 2, formulas and functions. Is it not working on that end?
The same link from yesterday, right?
No, it's a different link. I just posted it on Brightspace.
Oh, let me
I
check.
also
Sorry.
put it in the Zoom link too, like in the
Okay.
Zoom chat, if you want to use
Okay.
that.
Yeah, I see it. Thank you.
Yeah, of course. Yeah, that was from yesterday. Okay. So let's go over the question, right? So we want to make sure that we're doing PEMDAS here. So we have A2 plus A3 times A4. We want to do A3 times A4 first. So if A3 contains 3 and A4 contains 4, that becomes 3 times 4, which is 12. Then we add A2 to that and we get ourselves 14. And everyone got that correct. Good job, guys. All right. So today's lesson objectives are going to pretty much be a continuation of functions. We're going to go in depth a little bit more with a variety of functions and also a couple of the different ways we can look up specific data. We could filter and pretty much just kind of continuing with functions. So not too much today. Yesterday was kind of like the bulk of getting ourselves into Excel and everything. So today's lesson will be a little bit shorter, which is good. So again, just a reminder, the assignments, we're going to be doing, well, you guys have already worked on today's lab, which was continuing the assignments from day 1. So today there were new assignments that have just been assigned for day 2. This time, there's going to be 3 little labs that are going to be done in lab class. That'll be done tomorrow in lab, but if you want, you can totally get ahead of that. And there's also going to be the homework labs as well. that are going to be very similarly structured to the ones that are going to be worked on during class tomorrow. Likewise, again, two projects. Project one is going to be done in class tomorrow, and the project two is going to be done for homework. So if you want to get ahead, you're more than welcome to, but as of the current moment, all that you would really need to get done is just finishing up with all of the day one stuff. And again, if you're pacing yourself and you want to kind of do it a little bit later, maybe you didn't have enough time, maybe you were at work or something, that's totally fine too. Everything that is graded is due Sunday night. So it's in your best interest to get it done early, but if things happen, there's a lot of wiggle room there. But if right now you're pretty much good with everything from chapter one, then you are right on track. No need to worry. And just like before, there's also going to be another extra credit quiz as well. So again, these are not counted for like a grade, but it will count as extra credit. So if you do them consistently, those points will end up going towards your lowest grade. We'll work out exactly what that would be later on. Okay, any questions about any of the deadlines going on?
So the one that says Excel Chapter 2 Project 1, I don't have to complete that one?
No, that's going to be done in class during lab. Only the project two will be graded.
Okay. And that's the same thing with the one for Chapter 1. The mid-level 2 one is the one that's going to be graded, not the mid-level 1.
Yes, exactly. On
Thank-
my class page, I have it listed as one is being done in lab and one is being done in home as homework, but it gets labeled as project one is done in lab and project two is done at home. Is that clear?
Yes, thank you.
Yeah, of course. So yeah, the first set of assignments, 1 through 3, and project one will be done tomorrow in lab. The second set, homework 1 through 3 and project two, that gets done on your own. Alrighty, so with that being said, we will get started with the slides for the day. And I had posted all of these slides already on Brightspace. So you are all set. You can take a look on there. You could follow along on Zoom. You could follow along pretty much anywhere that you'd like. Okay, so as we kind of went over, we're going to just kind of continue on our talk about different functions. We'll be going over a lot more that we didn't get the chance to do yesterday, as well as how to filter and look up specific data. So we went over a little bit about cell references, but now there's two types of cell references. There's going to be relative and absolute. So when we were dealing with our previous spreadsheet, right? If let's say we had something like I had 1 and I had 2, right? So cell B4 has 1 and cell C4 has 2. So we know we can just do some sort of formula here. Let's say I want to add them together. I'm just going to say B4 plus C4. All right, cool. 1 plus 2 is 3. Easy peasy. Now, what's really cool is if I wanted to, I could drag this formula down and expand it. So if I had a bunch of other numbers here, I'm just going to do a really quick series here, and I'm going to do another really quick series here, right? And let's say I just want to keep adding these guys together. So 2 plus 3, 3 plus 4. Now, we don't want to have to recalculate that or even have to rewrite this formula. Okay, that's B5, C5, B6, C6. What's really great is I can drag and drop this formula and it automatically does this for me. So it automatically detects the pattern and it says, okay, well, this is B4 and C4. Now, because I'm shifted down one cell, I'm going to have to do the same thing to my formula. I have to shift the formula down one cell as well. And that is what Excel is doing behind the scenes. It's saying, okay, instead of doing B4, C4, shift down B5, C5. And it goes down, continuing on and on and on and on. And this works for all different types of formulas. That's great and all, but what about if I had a fixed number here? Let's say instead of doing B4 plus C4, okay, I want to only use the number 1 as my first number. So instead of just changing this first number to 1, 2, 3, 4, 5, 6, I want to hard code it, right? I don't want it to change from B4 to B5 to B6 to B7. What I can do here is I could add dollar signs around this guy. And what this will essentially, oops. Let me just double check that really quickly. Oh, that's what I had to do. That was what I messed up on. Okay, what I can do here, right, is instead of writing it like this, I can put dollar signs around the row and the column. So there's a dollar sign before the B and a dollar sign before the 4. Now, just going to delete these guys here. Instead of being like 2 plus 3 and 3 plus 4, on and on and on, if I drag and drop this guy, notice it changes. Now it hard codes the first entry as B4. That B4 is never going to change, meaning that in reality, I'm always adding 1 plus C5. Then I'm doing, oops, then I'm doing over here 1 plus C6, 1 plus C7, 1 plus C8, continuing on and on. So these are what we call absolute cell references. They are absolute. They are never going to change. Relative cell references are allowing us to do that kind of magical Excel where it's able to automatically detect where I'm shifting down or up in my formula. So sometimes you want to hard code an entry in that doesn't change. Like in my example, I want to always use 1. Maybe there's a percent that I always want to multiply by. Whatever it is, I can hard code it so that it is absolute. And it doesn't just have to be just relative or just absolute either. We could use mixed cell references too. Part of the cell reference will change and part will remain constant. If you noticed over here, when I put the little dollar sign, I put $1 before the B and $1 before the 4. What if I only wanted to keep within the same row and I only wanted to change the column? I could just get rid of $1 here. And this says only stay within the B column here, but the row can be changed. So only the column is going to be absolute, fixed. The 4, our row, is constantly going to change. So we can kind of see an example of this here, right? Relative versus with our relative, right? We're able to have it changed every single time that we use it. So we go from here, D2 minus E2, D3 minus E3, etc. So in an example like this, right, I'm just subtracting our house cost minus our down payment and see how much is our amount financed. So this makes it a lot easier when we're dealing with like a lot of big numbers that we don't want to calculate over and over again. But let's say I wanted to make sure that I'm only using the same percentage every single time. This is an example of when I'd want to use an absolute cell reference. The previous one, I wanted to make sure that I was changing it every single time because each of these rows is referring to a different down payment, completely different numbers. They're not related to each other. They're just using the same formula, but different numbers. This guy, on the other hand, though, we want to make sure that they're all using this down payment rate, this 15%. So we hard code that and we say $B, $4. And again, I could have said Maybe I want to make sure that I'm only using the B column, but maybe I want to shift my rows every single time. Or I want to shift my columns every time and keep my rows, right? I can choose which part I want to stay fixed by putting a dollar sign in front of the respective amount. So this is always going to be referring to this cell only. Otherwise, if I were to not have those dollar signs, I would be just going down and using the entire B column. So I'd be multiplying by 12, 0.3%, then 15%. That's not what we want. We want everything multiplied by 15%. Okay, does that make sense? Any questions? Okay, cool. Thumbs up. Awesome. Okay. So sometimes you might have some errors, which you probably have already seen before, right? And in case there is an invalid reference, for instance, if I put B5 here, well, B5 doesn't exist. So this is going to end up giving me a pop-up error, similar to the error that I got where I didn't put my dollar signs correctly. All right, so Excel is automatically going to pick up on issues, and either it will give you a pop-up error or it'll pop up in this little cell here and have something like hashtag error or hashtag value or something that shows you that it's not been working correctly. So just something to be careful of because sometimes we can just be like going on autopilot, copying everything as if it was like, oh yeah, I'm just totally going to copy it. It's not going to be a problem. Just be careful of what you're actually copying because if you just drag and drop down this entire column, well, you might be referring to a cell that doesn't exist anymore or never existed in the first place. Yeah, so again, we can mix whether or not we want to have absolute and relative cell references. That's totally fine. So in a case like this, row number is always going to stay the same. The dollar sign comes before what we are keeping the same. The B, the column, will change though. So this is going to say I'm taking D3 times B or going down C. And then 4, the row is going to constantly stay the same. So D times B4, D3 times C4, D4, E4, etc., etc., etc. So
I'm sorry, Professor. So if it wasn't with the dollar sign and you did D3 times B, C, and D4, then what would it be?
so if it was like this example right here, right?
Hmm.
Yeah. So if I dragged this formula down one box, let's say, right? So down here would be the formula D3 times C4, right? The B is going to change to a C because it does not have a dollar sign in front of it. But the 4 is going to stay consistent. So this is going to end up referring to this box over here, which is actually going to create an error because nothing is in this box. But if there was like 20% in this box over here, then it would become D3 times our 20%.
Mm. And if it was a dollar sign with the B as well, so D3 asterisk dollar sign B dollar sign 4, and you did that, it would remain D3, the same thing that I just said.
It would always be D3 times
Mhm.
B4, this 15%. So
Okay,
as you continue on and copy and paste the formula, it's always going to refer to B4.
got you.
Yeah, so you guys are going to get a little bit more practice with this when we do a couple of the lab assignments for chapter 2. So don't worry if it's a little confusing at first. And then you can always play around with the two, because again, every Excel spreadsheet you can pretty much structure in a million different ways, right? This might be a good application for some things, but maybe not other things. So it kind of all depends. So that's why it's great to, complete like the labs and the projects because you see a variety of different outcomes of using these formulas. So we kind of went over Excel functions before. We're able to pretty much do any types of calculations. Makes our life a lot easier. We can basically make Excel our calculator. When you have formulas or really anything that you're essentially programming, and Excel is kind of like a form of programming. That's why this class is called spreadsheet programming. There's always going to be syntax. This is like the computer's language, right? Just like how we have syntax in the way that we communicate. For instance, we have different types of words like nouns, we have grammar, we have all kinds of stuff like that. Computers have a various amount of rules as well that allow you to structure things. For instance, when we're doing, let's say, a sum function, right? It asks for two arguments, at least minimum of two arguments, something to add to something else, right? If you don't follow that syntax, then you will get an error, right? It's as if you're trying to communicate to someone and you're trying to order a pizza, let's say. You have to say, "Hi, I would like one cheese pizza." If I don't say that correctly, then the person at the pizzeria is not going to know how to give me my order. Same thing here. If I don't specify exactly what cells and what function I want to do in that specific order, it will not work correctly. So a big part of spreadsheet programming is understanding the syntax as well as those arguments that you're going to need. These are just your inputs that you're going to be putting in. You want to be able to know, okay, I have this function. It needs these inputs. Then it gives me the following output. Knowing that for all of your main functions will make it so much easier for you because then you have all these functions in your toolbox and it's super simple to be like, hey, I have to find the average. Well, I know how the average function works, so I can just plug it into the formula and boom, Excel does all the work for you. And even better is when it even auto-completes, right? We kind of have gone through that a little bit. Sometimes when you're typing it in, for instance, if I typed in, let's say, a sum formula, it'll pop up over here. It'll also pop up some other stuff too, but it'll usually go by your most recently used. So this makes it a lot easier because you could start typing something and it'll usually pop up right there and then. And if you don't click correctly, you get an error. See, I did not put the right syntax in. I did not put in my two arguments here. So because of that, it gives you a calculation error. You might get calculation errors. You might get value errors if some value doesn't exist. Anything with the hashtag in front of it, those are going to be your errors. So we went over very simple functions like adding, but there is an insane amount of functions that you wouldn't even believe are within Excel. So if I'm in my home screen right here on the ribbon, I can go over here to formulas, click there, and inside these little book icons are grouped formulas for anything that you could pretty much ever imagine. Recently used, has you recently used, or pretty much very commonly used formulas. So we've gone over some, right? We're going to be doing average. Average is often a very popular function as well, since chances are maybe you have to find the average of your grades. That's what I had for the grade calculator, which is on our syllabus spreadsheet. We're going to be also going through if statements, which is going to be kind of covering a little bit of programming logic later on. There's a couple of other things too. Count is counting the amount of boxes. We'll get into that in a little bit. If you want to find the max or the minimum argument, you can use that too. Yeah, those are pretty much commonly used ones, but you can literally see that there are financial ones. There's a lot of them here. So any of my accounting major friends, chances are you might know more about these than I do. And you might be using these a lot more than I would. There's logical. So we're going to be going over a little bit of logical programming. So you could think of it kind of as if you've ever done coding before, kind of very similar to that. If you haven't, it's not a problem. We're going to go through that later on. So don't let this intimidate you. If you have text, there's also a lot of text formulas that you can do too. So not everything's for numbers, right? I could do a variety of different things too, which we'll go over as well. If I'm dealing with the date or the time, I could do a variety of different functions here, right? There's even a function called today that just outputs the date. So if you need to ask what the date is, you can ask your spreadsheet what the date is. We're going to also be going over some lookup functions. So when you have a lot of data, you don't want to have to look at everything yourself. You want to have the spreadsheet do the work for you. So a lot of these functions will do that work for you, which is very helpful. If you're doing more advanced math, there's a variety of different functions here. You can do absolute value. You can do kinds of trig functions like cosine, sine, tangent, all kinds of things. There's a lot of things here. So it's not even just limited to your basic functions, right? You can honestly use Excel as a full-fledged calculator. But wait, there's more. These are more for like specific fields that you probably will never use unless like you're in like engineering or statistics. But it's good to know that any function that you can imagine is pretty much within Excel. So for naturally, we're not going to be able to go through every single function here. It would probably take way too many semesters to ever do that. And you would only be responsible for the functions that we'll be covering in the slides. So don't worry, it's going to be like more simpler functions that you're going to be doing. Nothing too crazy. I'm not going to ask you to like solve a trigonometric equation using Excel. Like that would be kind of crazy. Save that for calculus class, right? Okay. Formulas will often autocomplete. We went through that. And also, what's really handy is that these formulas, when they pop up, will also show the required arguments that you need in the function. So if let's say I had a function that I wasn't really too sure about, like, okay, what do I have to put in this function? Well, it's going to show you. For instance, sum. We know, okay, well, I need to add two numbers together, right? But if we didn't know that, it shows right here, number one, comma, number two. And we know that's how the sum function works. I take one number, comma, another number, and I can add it together. Or I could put a whole range if I wanted there too. I could put an entire row or column, put it right there, and it would sum up that whole thing. But let's say I had something that I wasn't as sure about. For instance, let's say I took the round function, right? So what I'm going to take a look at over here is the round function. Now, if I wanted to round a number, let's say it was something like pi. I'm going to just exit out of that and just say, let's say we had the number pi 3.1415. Okay, I want to round that only to like 2 digits, let's say. Right? We don't need like an infinite number. So what I'm going to look at is my parameters here. It's saying that I need to put the number, comma, the number of digits that I want. Okay? So the number that I want to round is going to be this guy, which is in cell E10. Okay, first parameter done, comma. Then I want the number of digits as my second parameter. So if I want to have it rounded to 2 digits, I just put 2 in the second parameter. Okay, close my parentheses and enter. And just like that, we've rounded our function. So even if you didn't know that there was a round function before, or maybe you needed a refresher and you wanted to see like, hey, how does this function work? How am I supposed to round something? Well, you put it in and it'll have a little prompt that tells you exactly what you need. And it even shows it in the formula builder too. So if I go over here, right, how do we get to the formula builder? I click on my little f of x, right? This is popping up as round because I'm on this function right here. And it actually shows you your parameters here as well. So it shows the number and then the number of digits, right? So if I wanted to, I could even change it over here if I didn't want to type directly within the formula. So that's also another option as well. So any function that you want to use, right? Even if you don't know how it works, Excel will show you how it works, right? If I took, let's say I take, let's just say the absolute value function, right? Absolute value, okay? You take in a single number, right? Let's say I want to take the cosine of something. I take in a single number. Let's say I want to take in an if statement, which we're going to get to in a little bit, right? It's going to tell you exactly how to structure this thing. So it's going to tell you, okay, you need this parameter here, this parameter there, and this parameter there. So any function that you need to know how to do is right here in your formula builder. And I mean, of course, you could just Google it up too, but Excel has it all right here. So you got pretty much every single formula right at the tip of your fingers right there. All right, so with that being said, all right, let's continue. So all of our functions are here, nice and organized for us at all times. Doing over all of that. So a couple of basic functions. Again, you are only responsible for the ones that we're covering here. Very basic functions, nothing crazy. I'm not asking you to do like multivariable calculus in Excel. Like this is an Excel class, not a mathematics class. So we went through some. If you want to take the average, I could find the average, right? Again, I could put in the numbers individually, or I could put an entire range, right? We went over the range notation. I could say A2 through A14 to show me everything from our A2 through our A14. Okay. I could do my average here, right? We went through our round as well. So this one was the one that we just covered. Now, round we know will always go depending on what the last digit is, right? So whatever this num digit is, it's saying, okay, I want to round this to the second place. Look at the next digit. If it's 5 or more, up the score. 4 or less, let it rest, right? So in a case like that, it's always going to round up if that last digit after this 2 is going to be 5 or greater, or down if it's less than 5, right? But if I want to always round down, or I always want to round up, well, there's functions for that. I could use the round down function or the round up function for that. So if your professor wants to be really nice and always round your score up, they can use the round up function. Or if they want to be really mean and always round your score down, there's a round down function as well. Let's hope that they're always going to use either round or round up and that they don't round you down, because that would really hurt if you have like an 89.9 and you can't get that A minus. Okay. So this is just a little bit of each of the functions, right? The only ones here that we didn't really look at, we did, okay, round up. Median, right? Mean, median, mode. We know mean is just the average. Median is like the middle number, and mode is the most common, right? Could find the minimum of a number, the maximum of a number, all kinds of things like that, right? So we can just pretty much do any of that kind of stuff just through our good old functions right here. Okay. Also, there's the count function as well. So if I want to count the number of boxes, I can count them using the count function. what if I wanted to count only things that were blank, right? I can use that using the blank function. What if I wanted to count things that were only full? Well, then I can use the count A function for that. So no matter what you want to do, right? If you want to skip over blank boxes, you want to count those blank boxes, you don't want to count the blank boxes, anything that you want to do, there's always going to be a function for that, right? So you can also nest functions inside of each other. So in the case of this bottom function, let's say I wanted to take the average and then round it. Maybe the average was something like a really long decimal number and I only wanted it to be up to a certain point. Well, you can just do it that way. You can do the average and then round it. So functions are always going to work from the inside out. It's always going to go from this average function and then do the round function. So you could think of it as like kind of like a nested doll here, right? It's going to take, in fact, I'll do a demo of that so it's a little easier to see, right? If I want to take the average of, let's say, all these numbers, all right, I'm going to take the average and I'm just going to select these guys over here, right? Okay, 3.5. Let's say I want to now round that so that it's a whole number. What I'm going to do over here is I'm going to take the round function and I'm going to surround this entire guy with that. However, we know the round function is going to need a second parameter. So this average over here is the first parameter. So from average B4 through B9, this is the first parameter, number. Then I go comma, and I say the number of digits, right? So the previous one, we had it going to 2 digits. Well, I'm going to just say 0 because I don't want it to be in I don't want it to be an actual decimal here, right? So we've gone from 3.5 now, and we've rounded it up to 4. Since it's rounding to the nearest whole number, hence the 0, and it's rounding this whole thing here, this average. So you can even see I clicked on this parameter here, number, and it popped up the original 3.5. I click on this parameter and it pops up that the number of digits is going to be 0. And you can put as many functions as you want inside of each other. You could put literally a whole string of functions. Of course, that gets very disorganized very quickly. You probably want to split it up into multiple cells, but it's an option. It does exist. All right. We're doing right. Okay, we're just going to finish up this last section, then take a little break. Okay. Lastly, there's also a sum product function. And for this, I'm actually going to show a spreadsheet that I had created for my own grading as well. So let's say that you had two things that you kind of wanted to multiply together. Let's say you had a percentage and you had a value, right? And then you wanted to add them all together. Okay, well, you could just multiply each thing individually and then add that all together, or you could use the sum product function. So instead of literally doing, okay, C3 times D3, C4, D4, C5, D5, and then summing that entire column up as it is up here, sum product is saying, okay, multiply everything within the range of C3 to C7, that's this over here, multiply this with D3 through D7. So I'm saying multiply this column by this column and then add that up. So this nice and organized formula is the same as doing all of these formulas, multiplying everything individually and summing it up. So I had used this for my own grading. Actually, for the grading of the grade calculator that we have for the class. That was right over here on a resource spreadsheet. So if you take a look, I have a little grade calculator here for you guys. And there's a couple of different things here. You could do your total points, right? This is the hard-coded total points that it's based upon, right? So this comes right from our syllabus, exam 1, 2, final, participation, etc. You could either enter your raw points here. So if I got, let's say, a 20 on exam 1, a 20 on exam 2, a 15 on the final, etc., and it'll add it up for you. So if you see right here, I have it as it's summing up from B5 to G5, right? That's the easy formula, just adding up the points. Now, I also have it so that you could also enter your percentage score. This is a little bit more complicated because I have to say, take your percentage score, right? And we're going to be multiplying it by this percentage over here, right? Because all these guys add to 100, so I can represent these guys as percentages. So if you notice, I've taken the sum product formula here. I'm saying multiply this column here, B3 through G3, right? And multiply that with whatever you put in this row over here, B7 through G7. And then just divide by 100 to get your total points from that. So otherwise, I would have had to say, multiply this with this, add it to this times this, add it to this times this times this. And that would have been a very long formula. This makes it so much easier. I put it condensed into one formula, and you can find your grade when things are weighted differently, right? You can't just find your average because not everything is weighted the same with the way things are structured, right? This is where 20 points, this is where 20 points, 25 points, 15 points. If everything was equal, yeah, you could just do the average, but you need a special function to handle the weights with that. So shows you, Excel is very useful. Okay. We went through the different date formats. So there's, you can use the today function to show the date. And with that, this is a great time to take a break. We're going to come back at 12 o'clock. So if you want to get a little fresh air, get a drink, go to the bathroom, whatever you need, we'll be back at 12 o'clock. Alrighty, so it's 12 o'clock. We're gonna resume with the amplify activity. So if you go to the amplify again, there's a couple of open questions right now. So you should be able to see from question 1, 2, 3, and sorry, it got out of order, question 5. So if you want to just answer from slides 4 through 7. So if you want to just take a few minutes to do that, and then we'll go over that. If you've done it already, which I see a couple of people did, then just continue your break. And also, we're almost done too. There's just like one more main topic to kind of go over, or like, okay, two more topics to go over, and then that's pretty much it. So, yeah.
Professor, are these lecture videos able to be downloaded?
The recording, you mean?
Yeah.
Yeah, so were you able to see the YouTube link that I posted yesterday by any chance?
I don't remember. I didn't see it. If it's on Brightspace, then I'll probably be able to see it.
Yeah, let me I'll show you exactly where it is. So if you go to content, I have the slides here, and then I have lecture recording links. So I'll be uploading the lab and the lecture as two separate recordings each time. And if let's say you go to the lecture, it'll lead you to a YouTube link. And from here, you can pretty much watch the entire lecture from that.
Awesome. Thank you,
And
Professor.
yeah, of course, I think you could even download it too if you wanted. Of
That's far. Bet. Thanks.
course. Alrighty. So let's go over some of the questions. So the first one, you have a data set in the range A2 through A14 that contains a mix of test scores, test nodes, like NA, and a few empty cells. If you want to find the total number of cells that contain any type of data, both numbers and text, which function should you use? So we know that the count function is going to count the number of boxes that we have, but we have a couple different varieties of them. We have count, count A, and count blank. Count is going to only look at full cells that actually have things in them. If we use count blank, well, that's only going to count the number of blank cells. We want to use count A. A is for anything, right? So any type of data, you want to use count A for that. And this also works for the other types of functions as well. Like if you're taking an average, there's average versus average A, sum versus sum A. You can pretty much use A to denote any type of data. So that way, in case you want to actually detect those blank cells and count them as a zero, let's say, you're able to freely do that. So again, everything has its own purpose in a way. You might want to use this if you're calculating, like, let's say, the average of someone's test scores, and maybe they forgot to take a test. So you want any blank scores to count as a zero. Then you want to use count A over count, because this would just ignore those scores altogether. Okay. Question 2, instead of calculating the inventory value for each item individually and then adding them up, you enter sum product C3 through C4, comma D3, D4. Use the pencil tool to write out the mathematical equation, showing how Excel calculates this result manually. And then use the text tool to type the final number result that Excel will display in the cell. So we got this guy over here, right? So I want to take C3 through C4. So C3 through C4. And then I want to take D3 through D4, right? So this is telling me that I want to multiply everything on this side by everything on this side and add it up. So I'm going to be taking 0.05 times 500 plus 0.25 times 500, right? So we're taking each of these guys multiplied by each other and then add the whole thing together, right? And it makes sense because think about what you're kind of doing here. You're saying the unit price and you're multiplying it by the quantity. So if I have 500 pencils and each of them is 5 cents, naturally I want to multiply them together to find the total amount that I want, well, that these pencils would cost. Then I do the same for the pens. 500 pens times 25 cents per pen, right? You find the cost of each of those guys, then add that up to get your total cost versus having to actually write out that whole gross looking formula as, okay, C3 times D3 plus C4 times D4. Instead, we have a nice organized sum product right there. Okay, any questions so far? Doing good? Alrighty, okay. So question 3 kind of relates to the first question. We have the following scores in a spreadsheet range. So we got a bunch of 90s and oops, looks like someone forgot to take their test, right? We have NA. If you use the basic average function, Excel completely ignores the text cell. However, if you switch your formula to average A, how does Excel treat the text cell containing that, right? Okay, so for this, I think it might be a little bit easier if I show it visually, right? So let me go through it. If I have, let's say, 98, 94, 92, 92, and I'm just going to say NA and 90. Okay, so we want to take the average of these guys, right? So I'm going to start by taking the average just generally, right? So this is completely ignoring this guy over here, right? It's just taking the average of all the cells that actually have a number in them. All right, cool, cool. Let's switch it over to average A. And let's see what happens. Now our score's gone down. This is now factoring this guy in as a 0. And we can actually show this by just changing this guy to a 0. The number stayed the same. Therefore, we see that if I have NA right? This is the same as saying, well, there's just no number there. It's text, right? So if I do average A, this counts as a 0. So again, if there's like students that took their quizzes, oops, they forgot one. Yikes, they got brought down to a 77. Good news is you guys don't have to worry about quizzes in this class. They're just extra credit. So you don't have to worry about your grade dropping for missing one. So Excel treats the cell as having a numeric value of 0. Okay, and the final one for this part right here, a cell displays the calculated value as 81.63636. You want to round this number to exactly 2 decimal places using standard rounding rules. So standard rounding rules is telling us we want to use round. We don't want to round down. We don't want to round up. We want to just round. Okay? And we know that the first parameter is going to need to be our number itself. The second parameter is going to be the number of decimal places. So we want to do round our number, comma 2. So this one over here is going to be for rounding 2 places. This one, as we did the example before, would round just to the nearest whole number. And these guys would just round down or round up respectively. So if it was asking for it to always round up, we'll use the round up. If it's only round down, use the round down. All right. Any questions about any of the questions that we went over? All right, cool. So we're almost done. We don't want to have to look through a whole boring spreadsheet ourselves, right? Let's have Excel do the work for us. We want Excel to handle the lookups. So we're going to go over a couple of different lookup strategies to find data that we're looking for. So let's say I wanted to find a certain piece of data, right? I can use VLOOKUP or HLOOKUP. So VLOOKUP, think V for vertical and H for horizontal. This is telling Excel, this is the order that I want you to search. V means vertical. I'm starting at the range that I specify, and I'm looking down vertical columns first. H, on the other hand, is going to be looking horizontally across our rows. So if let's say if I knew I had the data along the rows, right? I want to use HLOOKUP. It's going to get to that data way faster than if I were to do VLOOKUP. So it's just a matter of where is my data that I'm looking for? I want to kind of guide Excel to the right direction here. So we know that all of our functions tell us exactly what we have to put in them, exactly our arguments. So for VLOOKUP or HLOOKUP, right, I want to start with the value, right? Then I'm going to start with the array that I'm going to be using, right? That's going to be my table array. Array is just a fancy way of saying, okay, this is the range that I'm kind of looking for in this case, right? So over here, I'm saying, okay, I want to find my E3, and I'm looking through from A3 through B7, right? And from here, actually, I'm sorry, I'm looking for the number 2 here, right? And I'm looking through our A3 through our B7 here. And again, VLOOKUP versus HLOOKUP, same thing going on here. It's just a matter of, am I going to look vertically or am I going to look horizontally? Maybe I'm looking for the number, let's say 5, right? So I know I have a 5 over here and I have a 5 over here. And I have another 5 over here. Okay, well, if I were to look at it horizontally, the Excel would end up looking in this order. 1, 2, 3, 2, 3, 4, 3, 4, 5. Found the 5. Great. If I were to look vertically, on the other hand, I go 1, 2, 3, 4, 5. Boom, I found the 5. So this way ended up being a little bit quicker. So having Excel use it vertically would be much more efficient than if I asked it to look at or horizontally, because it would end up looking at these three values, nothing. These three values, nothing. These three values, oh, finally found it. Now, we're only dealing with a small data set here. Doesn't
Professor?
make a big, yeah.
Sorry, why would that be slower if it gives you the answer instantly though? Like I get what you mean in terms of like it's searching through more boxes versus vertically, but wouldn't it still give me the answer instantaneously?
So it would, unless there were multiple instances of that number that you're looking for.
Okay.
That's also another thing to keep in mind. For instance, I have a couple of different fives here, right? So the closest five, right, is dependent on if I'm looking kind of vertically or horizontally. Horizontally led me to this five. Vertically led me to that five, though. So it also depends which data that you're looking for exactly.
Mm.
But in terms of our speed, we do get the answer instantaneously. But if we're looking at a spreadsheet that's like a million by a million, we want to do it in the most efficient way
Yeah,
possible.
totally. Thank you.
Of course, good question. Yeah. So for the purposes of like spreadsheets that you would be doing, it's not going to be anything crazy. You're not going to be like looking through a million by a million spreadsheet like for any of these projects. So you don't have to worry too much about the efficiency of it, but it's good to still kind of look at it a little bit, like because in the real world, you might be dealing with way more data. You want to be doing things in the most efficient manner possible, just like how we did with the sum and product method, right? We don't want to have to multiply each in thing individually and add it up. That's a waste of our time and Excel's time too. And for something that is a really big data set, maybe it would take Excel a little bit longer, right? Excel is pretty powerful, but it could still crash, especially if you're using an older computer or an older version. Okay, so those are V and H lookup. There's also on newer versions of Excel, so probably what you're using on your computer now would support XLOOKUP. And XLOOKUP is essentially kind of like the best of both worlds in the sense that it does kind of like its own search simultaneously. So it will start looking vertically. If it doesn't see anything, it'll switch to horizontally. So this is kind of like that best of both worlds. And you could think like X, okay, the X is like a combination of vertical and horizontal. So this is kind of allowing us to look in both directions at the same time. And also, that's important to keep in mind because, again, which five are we looking for? Are we looking for this five or are we looking for this five? Or do we literally not care? If we just want to find a five, right? We just want to find it the quickest way possible. Or maybe this column over here is referring to a completely different thing than this part over here, right? Maybe if we were dealing with like prices or something, this is dealing with the price of a pen and this is dealing with the price of a pencil. Might sound kind of trivial, but for something dealing with money, you don't want to mix that up. So you want to be very careful with exactly what you're searching for in that case, right? So this is kind of just an example of that, right? What are we looking for here, right? We're looking for uh, the value in E3. So what is our E3 is going to be 85, okay? And we're looking within this range over here. Where are we going to return that? We're returning it in the second column. That's where we have over here, right? So it's returning that right there. So it's saying, okay, I'm looking for that 85, right? That 85, all right, well, I know 85 is within this range over here, right? So it's automatically going to detect and it's saying, okay, that's going to give me a B, right? 85, well, it's not within here. Specifically, it's between 80 and 90. So it's going to say, all right, well, it's closest to this guy over here. So boom, that's going to return the B. Where am I going to return it? I want to return it in my second column right there. And the same thing could be done horizontally, right? This was done vertically. If our grades looked a little bit more similar to something like this, where it's horizontal, right? The only thing we have to worry about changing here is number one, changing it to H lookup, and then changing the range as well, since now we essentially transposed or switched our rows and our columns. So it's a slightly different range. It's no longer just A3 through B7. Now it might be, let's say, A3 through B whatever at this point, or whatever the coordinates of these cells would be. But we essentially shifted it so it's no longer vertical. So again, just keep in mind, where are we essentially searching? Are we searching for things vertically, or are we searching for things horizontally? Otherwise, if you use the wrong one, you might waste time, and you also might get the wrong number in case, let's say, in our example with the 5, there might be multiple instances of 5s. Might be looking in the wrong place. And you can also use a variety of different functions with this too. Like, you're not just limited with just looking for something and just outputting it out, right? Anytime that you have an output from a function, lookups included here, right? I could do something with this. If, let's say, instead of a letter grade, it gave us a final score instead, maybe it was reversed. I could find the max, I could find the average, I could find the minimum score, right? Maybe I wanted to find someone's minimum score and delete it, right? I want to drop your lowest score. So I could use let's say, a min function instead of a max function, and I could find your lowest score, and I could change it to whatever it is. Maybe I want to give you a free 100 if you do all of your optional quizzes, right? So I could say, okay, find the minimum here and just change it to a 100. So you can do all kinds of nested functions just like this. So even if it looks a little bit more confusing, remember, we can click on these parameters just like how we did before, and we can find exactly what it's referring to. We know that in VLOOKUP, I have the max function, right? So this max C4 through C10 is my first parameter of VLOOKUP. I work from the inside out, right? I do this guy, then I plug it into VLOOKUP because this is just going to give me a max score, just the number, right? If let's say this number looks like 98 is the highest, right? This would end up returning just the number 98. I plug that in, 98 through E4 through F8, comma 2, right? And that's immediately going to look and say, okay, that 98, well, in this range, it corresponds to an A. So I'm going to give the second column, what is that? It's an A. So it's automatically converting, checking for where that 98 is, right? It's in this range and giving me the second box that corresponds to this value. That's how I get my A over here, right? If this was asking for, let's say, the minimum value, right? The minimum value is like a 56. Looks for the 56. Okay, 56, well, that is over here in the F range. Give me the second column here. That's going to be an F. Instead of an A, it would be the F here. So you can nest all kinds of functions. You could use average function. You could use sum function. You can use pretty much any kind of function that you want here. Okay. And again, XLOOKUP kind of does both. So it's going to start by doing that vertical lookup first, right? It's going to find it. So it's going to just end it there. But if, let's say, it wasn't there, maybe you had your data in horizontal and you didn't know that. So you just said, okay, just do XLOOKUP by default. You would realize, oh, shoot, I can't find the data. Switch to horizontal then. And all of this is just going to return a single value. It looks crazy, but it returns a single value from there. So even for something like here, right, you just end up getting a single value, and you can plug this into more and more functions as you go along. Okay, so that's not too... Okay. All right. So that is pretty much our lookup function. right? We're going to get more practice with that while we do the lab. So we're going to go back to Amplify for the last question really quick. And then let me just open that up. So you should be able to access on slide 8, the last question there. So we have that, right? We're given VLOOKUP E3 in this range, comma 2, right? And we're asked what it's going to return in this case. So we're just going to go through that. Alrighty. So we're looking up VLOOKUP. We see E3. All right, E3, right? E3 is right here. It's an 85. Okay, I want to output what the score corresponds to within the range A3 through B7. All right, A3 through B7. That's these guys. All right, where is 85 in here? 85 is right here, right? This means it's corresponding to a B. It's within the B range, right? Because between 80 and 90. But a 90 is going to mark off an A. We stay within the B range. So everything from like an 80 to an 89.99999 is going to give me a B. So this B over here is going to get copied right there. And again, if this was, let's say, a 90, right? 90 corresponds to an A. 91, an A. If it was something like a 75, right? I look here, I'd have to be within the C range. I would end up returning a C. So I'm looking at whatever range I'm in, right? Whatever this first parameter is telling me, all right? 85, whether it's an 85, whether it's a 65, whether it's a 75, whatever it is, I'm looking to see what range it is in. And whatever range it's in, that's the score that's going to pop up. Okay. Any questions on that? All right, let's finish off strong. This is the last topic over here, and we'll go over this a little bit more next time, since this is kind of going to be our start of like more real programming in a sense. So if anyone here has done coding at all or CS, this might look familiar for you in the sense that we're going to be doing if statements, right? We're doing functional logic. So This looks like a lot of stuff going on, but we're going to break it down into pieces, just like we did with all of our other functions, right? This is saying if this condition is true, then do this, else do this. So if E2 is greater than B $2, okay, remember that means I'm hard coding 2. So if I'm passing this function down on and on and on and on and on, I am keeping the row 2 consistent. So if E2, right, that's 11,000, is greater than B2, B2 is 10,000. All right, 11,000, yeah, that's true. 11,000 is greater than 10,000. That means I set this cell to be B $3, not the 0. So what is B $3? Well, that is going to be 500. So that's why we have 500 here. If instead of 11,000, if this was 9,000, that would mean 10,000 is not greater than 9,000. This condition is not true. Therefore, we choose the second box. And if we drag this down, remember, we're keeping the 2 and the 3 constant, meaning we're always comparing to our sales goal and the bonus. We are not changing it, right? Even though the B does not have the $sign, what are we doing here? We're dragging it downwards, right? We're staying within the same B column. We're not changing that B at all. So there's no need to have the $sign. Whether I have $sign B or no $sign B, the only thing I care about here is by keeping this B $sign 2, well, as I drag this guy down by row, all I'm doing is also dragging the reference down here, 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 on and on and on. All I need to lock in is my row. I don't need to worry about my column because the column's not changing. If I was dragging this way to the right, on the other hand, then my column is changing and my reference would be changing too. So I got to be careful on that note. So kind of tying it all together in that case.
So, Professor,
Yeah, what's up?
so if you were to drag down from F, that green box, right? The
Mhm.
next number that would be there would be what? Because it's tied now to 10,000.
Exactly. Great observation. So this is saying if E2 is strictly greater, is 10,000 greater than 10,000?
No,
So what are we going to return then?
false.
Exactly. So that's going to be 0.
Yeah, as well as the one under that, right?
You
Right.
got it. Yep. Yeah. So if you wanted this to be not strictly greater than, right, then you'd have to make this greater than or equal to, right? And we can do that by having the greater sign and then an equal sign after that. So that's kind of like a little trick here, right? I have to keep in mind, is E2 strictly greater than B $sign 2? Unfortunately for Jose, you only got $10,000. You just met the sales goal, but you didn't get your bonus because you have to be greater than the sales goal. So poor Jose and poor Rex. You guys were so close. Only Tiffany got the bonus, it seems. So it kind of helps to draw these guys out as a flowchart, especially if you're new to logical programming like this, right? Because you're probably like, whoa, if else, what's going on over here? So think about it, right? Say it to yourself. If this is true, do that. Else, do that, right? We said, okay, if the sales goal was greater than 10,000, we set it to 500. Otherwise, we set it to 0, right? This allows us to kind of think of it as a computer would think of it. Computers think of things in terms of Booleans. A Boolean is just a true or a false value, right? That's why we're thinking, if this is true, do that. If this is false, do that. Best way of thinking about it is a light switch. Is the light switch on or the light switch is off? That's what the computer is really doing in the background here. If this is true, right, I turn my light switch on. I set the value to 500. If it's false, I turn the light switch off. So this is kind of very related to computer science as well. So if you're interested in all of that, I recommend taking CSCI 111. And there's a variety of different comparison operators too, right? So in this example, it was strictly greater than. If I wanted it greater than or equal to, just as I said before, I just write greater than and then equal consecutively. So we know that if we were to just draw it out, we would write it out as a greater than sign with a line underneath. The computer is not able to read that. So we have to actually say the greater than sign and then the equal sign. And all of these guys are the other things that you can say, right? We can say equal to. Not equal to is a little bit weird to think about, but it's essentially the less than sign and then the greater than sign. So it's like you're shrugging your shoulders like, sorry, it's not equal to it, right? We can't decide, right? It's not greater than, it's not less than, not equal to. So this will be kind of like a little guide. So you can pretty much create any type of operation from this right here, right? So whether something's equal to, whether it's less than, not equal, etc., right? And you don't have to just set it to numbers either. Here, I have, if A2 is not equal to A3, just output not equal. Otherwise, output equal, right? So it shows and it outputs words instead of an actual value. So you have that option. And again, you can string so many different functions together. I could say if A2 is greater than A3, do the first thing here, A2 times A4. Otherwise, do the second thing here. Take the max of A2 times A5, comma A6, right? So there's a lot of stuff going on here, but break it down per comma, right? Between this comma, this is the first parameter. This is the second parameter. This is the third parameter. And that is the end of that. Okay. So yeah, if you have any questions, otherwise, if you could fill out the check at the very end of the amplify page. And if you have any questions, I'll be here. There's also going to be office hours as well. I'm going to be in the Learning Commons from like 1 to 3 today. It's like really quiet. So if you need help in this class or any other class, I honestly recommend that you go. You could attend in person or online. It's totally fine. Kevin as well is going to be working in the math lab. So also 1 to 3, right?
Yeah.
Yeah, also 1 to 3. So if you need help with anything, or if you just want to chat, like literally it's like nobody's there. So yeah, stop by. Kylie Hall 131 is the Learning Commons, and Kylie Hall 331 is the
Yeah.
331? Yeah, Kylie Hall 331 is the math lab. Or you could just email us. Again, we're open. And yeah, otherwise, uh tomorrow we're going to be starting in the lab all of the lab activities for chapter 2. If you want to get ahead, you can. Otherwise, honestly, if you get through all of chapter 1 stuff tonight, you are in great shape. So, otherwise, enjoy the rest of your day. It's absolutely beautiful weather outside. Try to get outside. And again, ask us if you have any questions.
Thank you, Professor. Have a good one.
You too.